Hi everyone. So we are going to look at chromatography as a separation technique. So when we do chromatography, you're going to have the sample, and the sample is going to be normally a mixture of colored substances. You know that chroma means color. So normally chromatography is used to separate colors that are mixed together, dyes that are mixed together. So the sample spot is going to be put on a line. This is called the baseline, and this baseline is usually drawn in pencil so that when chromatography happens, the pencil, like ink or dyes from the baseline, do not separate also. So that's why it's in pencil. Now this is called the stationary phase. The paper in the paper chromatography is called the stationary phase. Stationary means that it stays fixed. It does not move. It's a fixed part of the chromatography. And then you have the mobile phase here. The mobile phase is the solvent that we use. It could be water, it could be a mixture of water and alcohol, it could be only alcohol. And it's this part that will move up. So that's why it's called mobile phase. It's going to move up the paper. It's going to move up in the stationary phase. Now when we draw the baseline must be above the level of the mobile phase, above the level of the solvent. If it is below the level of the solvent, then the sample spot would mix with the solvent, which we do not want. So the sample should be above the solvent, so that when the solvent moves, it carries the sample spot together with it on the stationary phase. Now, why is it that the solvent or the mobile phase will carry the components of the sample? This is because the sample, the molecules in the sample, form interactions with the molecule of the solvent. The more you have interactions between the solvent and the sample spots, the more there's interactions, the more it will be soluble in the solvent. And the more soluble it is in the solvent, the more the solvent will carry it along with it up on the stationary phase. And the stationary phase, this is the chromatography paper. So if you look at the colors here, you see that there is like this green and then there is purple. So the purple forms stronger interactions with the solvent. So then the solvent is able to carry the purple along with it higher on the top. So this means that the purple is more soluble in the solvent compared to the greens. So the greens are the least soluble and the purple is the most soluble. That's why the mobile phase or the solvent carries it further up the chromatography paper. Now, once the solvent has reached almost at the end of the chromatography paper, we're going to stop the chromatography and we are going to draw the solvent front. The solvent front is the maximum height that we allow the mobile phase to go up to. Normally, a chromatography, like paper chromatography, is done in a sealed jar or a sealed beaker. We use a cover to ensure that the solvent does not evaporate. For example, if we're using alcohol as a solvent, because we know that ethanol or alcohol is volatile, so to avoid it evaporating, we cover the chromatography jar. So this is a recap of chromatography, of paper chromatography. Now we have other kinds of chromatography. We also have gas chromatography, liquid chromatography, which is also called HPLC chromatography, which stands for high performance liquid chromatography. And you also have thin layer chromatography. Thin layer chromatography is very similar to paper chromatography, but instead of using paper, we use a glass slide or an aluminum slide, which is coated with a layer of silica gel. So instead of the stationary phase being paper, the stationary phase is a layer of silica gel. So then the sample is going to move up on silica gel. So it's like a white layer coated on either a glass slide or an aluminum base. Now, chromatography, when you look at it like this, is mostly qualitative. So there's no values involved when you look at it like this. So to make it quantitative, we use the RF value. Now, to calculate the RF value, you will have to do a ratio between the distance covered by the spot and the distance covered by the solvent. The distance covered by the solvent, this is the distance from the starting line to the solvent front. That's why the solvent front here is very important. So the distance here from this to this is the distance covered by the solvent. Let's call it Y. So this is going to be over Y. Then the distance covered by the spot is the distance from the starting line to the center of the spot. So if you look here, this is the spot. So this is the spot here. I'm going to find the center of the spot. It's here. I will draw a line here. So then to measure the distance covered by the spot, it's from the starting line to here, to the center of the spot. Okay, so then this is X. So then RF value is X over Y like this. And RF value, if you find it correctly, it will always be less than 1. So it's always going to be 0 point something because it's a small value over a big value. So if we find the RF value of B here, so it's going to be, you have to be very careful here. It's not 0 to 1.9. It's this value here. So it's 0.5. And this is 1.9. So this is going to be 1.4 divided by. So this is 6.0. So then the distance here is not 6. Is 5.5 because we are starting, the starting line is on 0.5, not on 0. So this is a very common mistake. So be very careful with it. So it's 1.4 divided by 5.5. It's small value divided by big value. And I'm giving my answer to 2SF. Why is this 2SF? Because this is 2SF. And this is also 2SF. So then my answer is 2SF. We're going to go into more details about how to choose SF and DP for your final answer based on the SF values that you use in your calculations. So we're going to see that in class. Now one last thing to pay attention is that whatever you use as the mobile phase, as a solvent here, should be something that is able to dissolve the sample, or at least part of the sample must be able to dissolve in the solvent. If it is insoluble in the solvent, the point will not rise, so you will not get anything in the chromatography. So you will only get some spots that rise like this if the sample is soluble in the solvent. So you are going to pause the video and you're going to try question F and G. Once you're ready, you can play the video again for the correction. So identify the stationary phase. Stationary phase is paper. It's the part that does not move, so it is paper chromatography. So the paper is a stationary phase. And then an example of a mobile phase, you could give anything actually. You could give water, or you could say ethanol, or methanol, or any alcohol. And why do I say water? Because it says that these dyes are soluble solids. So generally when we say soluble solids, they are soluble in water. So that's why water is a good solvent for mobile phase. Then state which dye, A or B, has greater affinity to the mobile phase. Affinity means liking. Liking, which means interactions. So which dye, A or B, has greater interactions with the mobile phase? So if it has greater interaction with the mobile phase will carry it further up. So it's A that has greater interactions, greater affinity. Why? Because it has moved further away. Or you could also say that it has a larger RF value. You do not need to calculate the RF value. If you look at the ratio, this ratio to this ratio, you can easily see that A has a greater RF value. It has moved further up the paper. So with this, we've finished the explanation for today. You're going to do a few questions. So as classwork, that is going to be continued as homework. You will do question 3, 4 from the end of unit questions as MCQ, and you will do structured question 1, ABC, and you will do question 3. This is completely on chromatography. It's good practice. So that will be it for today. Thank you. Have a nice day.